Hello everyone. This lesson is focusing on the C over A, and it assumes that you've already been through Introduction to Biomechanics, you have some understanding of biomechanics, and essentially is a review of the C over A itself. So essentially what we're looking at here is, if you look at the occipital condyles and where they articulate with C1, and if you look at the C2 superior articulating surface where it articulates with C1, there are this arc to the articulation, and you can take that arc and continue it to where it will scribe a circle that we call the condylar circle up above, and then same thing down below on the axial surface. You can continue along and scribe a circle, and that we call the axial circle. Now, this was first observed by Dr. A. Wernsing, and he discusses this in his book Atlas Specific. He then further went along saying that if we introduce a force into the Atlas transverse process, then that force can be distributed via the lateral mass, as it has kind of a wedge shape to it, both distributing force into the occipital condyle as well as the axial surface on the same side that you're introducing the force into that lateral mass. So as we look at it, and we look at the sizes of these circles, the question is, which circle will rotate more? Is it the upper circle or the lower circle? Well, in order to understand this a little bit further, we have to get into some basic physics. And if we look at this antique bicycle, let's say we get on the bicycle, we pedal it for exactly 1 mile. The question is, which of the wheels, the back wheel here, the smaller back wheel, or the larger front wheel, which of those two wheels is going to do more revolutions over the course of pedaling for that 1 mile? And the answer is the smaller circle. It's going to have to do more revolutions over that period of time because it is just smaller in diameter. And so when we look at introducing a force into the C1 transverse process, distributing the force through the lateral mass into the condylar circle and the axial circle here, the smaller circle is going to tend to rotate more easily, okay? And that's the fundamental concept you need to understand here. So let's look at this. This is a more realistic example of what we typically see, where the condylar circle is smaller than the axial circle here in terms of diameter. And so when we look at the C over A, or the Condylar-Axial Relationship specifically, in this example I'm showing where the circles are equal, and this is just for simplicity's sake. We have a calculation. Since this is an anatomical constant for the patient, the diameter of these two circles does not depend upon the patient's misalignment, or the structural shift of the atlas. That doesn't change. So this constant allows us to figure out a starting point from where the height vector should come when we're trying to figure out how to get a perfect vector for the frontal plane, the Nasium view, perfect vector to correct whatever subluxation the patient has. So the calculation here is A minus C, so the diameter of the axial circle, minus the diameter of the condylar circle, and then we take the remainder of that and we divide it by 2, and that equals the C over A. So in this example, it would be 3 minus 3 divided by 2 equals 0. So a height vector of 0 inches would be the C over A value in this example. And so if we remove the actual structures here and just kind of simplify it with a line drawing, we've got the central skull line here, the angular rotation line going straight through the cervical spine, and then the atlas plane line here with the atlas depicted with the figures. Here is the 3-inch condylar circle, 3-inch axial circle. Again, 3 minus 3 divided by 2 equals 0, and we have a C over A with a value of 0. So what that means is we don't want to come in from above that or below that. In order to get the force equally distributed into the condylar circle and the axial circle, you would deliver a force at 0 inches. Okay, so here is a more realistic example again. Every once in a while you'll see those circles the same, but the majority of the time the condylar circle is going to be smaller than the axial circle. And in this example, the condylar circle is 3 inches still, but the axial circle is 7 inches, again, which is more typical. So with the calculation that we had before, we subtract the axial circle minus the condylar circle. So in this case, the 7 minus 3, and then we take the remainder of 4, divide that by 2, and we end up with a 2-inch value for the C over A. And so in this example, even though we're showing a positive value for the C over A, this 2-inch vector coming in like this still delivers the force equally into the condylar circle and the axial circle, because remember, this smaller circle is going to tend to rotate more easily. So again, simplifying this, taking away the structures, 3 inches above, 7 inches below, 7 minus 3 divided by 2 equals a 2-inch value for that C over A. So a height vector at the C over A essentially is the 50-50 relationship of the force being distributed into the two circles. So if we take a height vector below the value of the C over A, is more force going to be directed into the condylar circle up here or the axial circle down here? Well, if we deliver a force at the C over A, if that is going to distribute the force equally into the condylar circle and the axial circle, then if we come down and have more and have a height vector below the C over A, then that is going to direct more of the force up into the condylar circle. Okay, the further below the C over A we are, the more of the force is going to be distributed into that condylar circle. If we have a height vector above the C over A, then are we going to be delivering more of the force into the condylar circle or the axial circle? Well, remember, with the C over A delivering the force equally, 50-50 distribution of the forces into the two circles, then if the height vector is above the C over A, we're going to be distributing more of the force into the axial circle, and the further away from the C over A the height vector is, the more the force is going to be distributed into this axial circle. And this concept is fundamental for deriving and calculating the height vector for the NUCCA correction from the Nasium view. So no matter the value of the C over A, it always represents the 50-50 vector, or essentially your starting point. Remember, this is an anatomical constant. This does not change from one x-ray to the next on a patient. And one kind of advanced tip on this is that if you are analyzing your x-rays and you're seeing that you are getting different axial circles, or condylar circles for that matter, that really isn't changing. You're just seeing it differently, and you need to take a closer look to come up with the appropriate measurement there. So again, in summary, no matter the value of the C over A, it always represents the 50-50 vector in terms of distributing the force equally into the condylar and axial circles. Please leave your questions in the comment section below, and I'll make sure to answer them for you.